avances tecnológicos. Comprometida con la construcción de un mundo sostenible, la Universidad de Monterrey abre hoy este espacio de aprendizaje y reflexión, buscando generar conciencia e invitándonos a emprender acciones de cambio que contribuyan al cuidado del medio ambiente y a la calidad de vida de las futuras generaciones. Agradecemos la presencia de algunos miembros de nuestro Consejo General y Ejecutivo que nos acompañan con motivo de la Asamblea, de directivos, profesores, nuestros estudiantes, por supuesto, algunos exalumnos y amigos de nuestra institución. Gracias a todos por acompañarnos esta mañana. Quiero solicitarles de la manera más atenta si nos ayudan apagando sus teléfonos celulares. No va a pasar nada en una hora y 15 minutos. Y sí necesitamos que no haya interferencia para que los micrófonos funcionen adecuadamente. Muchas gracias. El famoso arquitecto español Antonio Gaudí se refirió a la naturaleza como un gran libro siempre abierto que los seres humanos tenemos que esforzarnos por leer. Esta tarde, el mensaje de Crossroads Project nos invita a hacer un alto para leer ese maravilloso libro que es la creación. The Crossroads Project está integrado por Robert Davies, doctor en física, catedrático e investigador de la Universidad de Utah y de la Universidad de Oxford. El doctor Davies fue oficial y meteorólogo de la Fuerza Aérea de los Estados Unidos y trabajó en el proyecto de la Estación Espacial Internacional de la NASA. Integran también el espectáculo multidisciplinario los violinistas Robert Waters, Rebecca McFaul y Bradley Ottesen, y la chelista Anne Francis Bayless. Juntos ellos conforman The Fry Street Quartet y han realizado presentaciones ante numerosas audiencias en Jerusalén, Sarajevo, Austria, Brasil y Estados Unidos. Estamos muy contentos de tener hoy en la UDEM, por primera vez en México, dejo con ustedes a The Crossroads Project.
Music. Vibrant, powerful, beautiful, complex music takes me to places in my mind I just don't seem to go otherwise. It's like a spark igniting pathways that otherwise lie dormant. My thoughts move in unexpected directions on whatever's hovering in my mind when the music plays. I'm not alone in this either. Einstein attributed his inspiration to the theory of special relativity to music.
It occurred to me by intuition, and music is the driving force behind this intuition. My new discovery is the result of musical perception.
And so, as I was listening to the music just now, I was thinking, this device has no moving parts. 200,000 years ago, we humans woke up on this planetary island in the universe. And today, we humans have arrived at this. And this. Well, you might say 200,000 years of learning, it's got to take you somewhere. But in fact, nearly everything we know about our island planet, nearly every piece of knowledge and technology we possess, we've acquired in just the last few hundred years. Two 1,000 centuries from there to here. And nearly everything we know about our world, we learned in just the last two. And what has distinguished these past 2 centuries from the 2,000 that came before was the emergence, just a few hundred years ago, of one of humanity's great endeavors, our enterprise of rigorous science. As a system for acquiring knowledge, it is unequaled. Knowledge that astonishes and serves and forewarns.
Human beings and the natural world are on a collision course. Many of our current practices put at serious risk the future we wish for human society and may so alter the living world that it will be unable to sustain life in the manner that we know.
The rantings of a mad violist? Unfortunately, no. The words of the world scientist's warning to humanity, written in 1992 and signed by, among many others, nearly all of the Nobel Prize-winning scientists of the day. So what do we think when we hear words like these from people like these? Do we even take notice? Do we want to understand? Perhaps respond? Understanding this warning is straightforward. We need only recognize that we don't happen in a vacuum. That our society is a structure with its pillars of food, energy, and economy embedded in a much larger structure. Enveloped, in fact, by this whole earth system. It is this earth system of water, soil, climate, life, that makes our civilization, indeed our very lives, possible. And if this system is imperiled, well then so are we. Not so difficult to understand. But to respond is something different. Because our scientific system of knowledge is telling us today that meaningful response to this warning will require extraordinary achievement. We need to change direction rapidly and radically. And because our inertia is enormous, so too must be our impulse for change. And generating such an impulse requires not only an intellectual understanding of the problems, but also a deep, visceral comprehension. We need to feel the paths we're choosing and the paths we're not, and to experience in our own minds the very different destinations to which these paths lead. So having this experience is our journey this morning. A journey that confronts difficult realities, to be sure, but also one that explores human achievement and potential. Because in the 20 years since the world scientists issued their warning, our impact on our world has not tempered, it's intensified. Geologists refer to Earth's present age as the Anthropocene, a time of human impact on global systems so significant it constitutes an entirely new geologic era. One veteran ocean researcher recently remarked on this new era.
The world's coral reefs are on a trajectory to collapse within a human generation. They will be the first, but certainly not the last, major ecosystem to succumb to the Anthropocene.
And so it seems we've arrived at a unique place in our history. A time when, for the first time, our system of knowledge permits us to identify enormous risk decades in advance, but our system of living prevents us, so far, from responding to this knowledge. Well, the time for this has passed. We know, through our hugely successful enterprise of rigorous science, we know where we are, how we got here, and where we're going. And in the words of the French photographer and naturalist Jan Arthus Bertrand,
the time has come for us to believe what we know.
The time has come for us to believe what we know. Planet Earth, planet water. 2 hydrogen, 1 oxygen, 3 atoms arranged just so. And from this structure emerges the extraordinary. As a physicist, I want to tell you everything about it. Just you, me, the polar covalent bond. But that would take a week or a month. So tonight, this morning, we'll focus on just those properties of water that give rise to life. And we all know that water is important to life, but do you really know why? And the answer is yes, through science, we do. It is no accident that the water planet is a living planet. Through water, the climate of life emerges, and in water, the chemistry of life unfolds. First, the climate. In the atmosphere, water vapor is a powerful greenhouse gas warming the planet. At the poles, frozen water, vast ice sheets reflect vast quantities of sunlight, limiting the greenhouse warming. And in the oceans, liquid water absorbs enormous amounts of energy, transporting it from equator to pole. And from this synergy of warming and cooling and transporting emerges a climate essential for creation's only known biosphere. All from this simple structure of 2 hydrogen, 1 oxygen, 3 atoms, arranged just so. And so water creates life's climate, and then it creates life itself. In water, nutrients can dissolve and self-assemble, first into building blocks and then into living structure. Life's chemistry of metabolism, respiration, photosynthesis happens only in water. As a bonus, Water's electrical nature makes nervous systems possible, facilitating jellyfish and cockroaches. Homer Simpson. So in water, simple life began. Through water, complex life emerges. And so this is what our enterprise of science tells us. This is why all known life needs water. And while water may seem plentiful on the water planet, only a sliver, about 3%, is fresh water, and only a sliver of that is available to us. At the end of the day, only 1 drop in 10,000 is ours to use. And so all of this science tells us about water. And a little more. From water purity to water supply, all is not well with humanity's water. How much are we free to waste? How much are we free to pollute? Glaciers quench thirsty billions until glaciers disappear. Planet Earth, planet water, planet water, planet life. So much life, ancient, diverse, everywhere. More than 1 million species cataloged so far, a small fraction of the roughly 30 million species believed to exist. The sheer variety, this biodiversity, is breathtaking. And complex. Tapestries of living systems, ecosystems, life and environment interacting and interdependent. It's perhaps the most important lesson science teaches us about life. That Earth species are not separate from their environment or from each other. Life arises from environment, self-assembles like a snowflake, reforms its environment, and is then itself reformed. Evolution through an environment's natural selection. And life on Earth is not only 30 million species, but 30 million components of a vast, self-limiting, self-repairing, self-assembling ecosystem, machine. And though our current understanding of this machine is rudimentary, ignorant of most of the components and their connections, we do know some of its operating principles. We know natural systems are diverse, and this biodiversity means resilience. Not a single species of pollinator, but many. Not a single source of food, but a melange. Not a single habitat, but many. And not a collection of keystone species without which no one else can survive, but a tapestry of complementary, overlapping elements, reinforcing each other and serving each other. We know that natural systems produce no waste. They are closed systems, and what is waste for one organism is nutrient for another. The carbon dioxide I exhale is taken up by my ficus. In natural systems, nothing is thrown away because there is no away. We know each species serves the others in what science cleverly calls ecosystem services. Wetlands purify water, soils and pollinators produce food, plants produce oxygen, the list goes on and on. We know there are key segments to the biosphere. Most of the world's new life, for example, comes from coral reefs, wetlands, and tropical forests. We also know that ecosystems can be driven to permanent collapse. 5 times this has happened, the fossil record tells us, each time triggered by rapid environmental change. Though life is resilient at all levels of the biosphere, it is apparently not infinitely so. Finally, we know that all is not well with life on our planet today. Earth's biosphere is in a rapid transition. Consider these words appearing just a few months ago in the prestigious scientific journal Nature. Humans are now forcing a planetary-scale critical transition in the biosphere, with the potential to transform Earth rapidly and irreversibly into a state unknown in human experience. The biological resources we take for granted at present may be subject to rapid and unpredictable transformations within just a few human generations. Tell me then, which of us in this room, in wisdom, stands before this great machine and identifies the pieces that are not needed?